So let me quickly launch Wireshark application on my Kali Linux box for you. Right, I'm just going to type wire, and there you go. Wireshark tool is visible now. I'm just going to hit enter and open that for you. All right, and that's the Wireshark tool open. All right, and this displays the number of interfaces that are available to be worked upon. Okay, so as you can see here, there is some spikes that are moving, which means there is enough amount of traffic for the tool to inspect and analyze. So we will quickly select this interface and start capturing the traffic or the network packets. All right, how are we going to do that? Just select that one, and also and just say begin starting capture. You can see here there is a shark symbol that says start capturing packets. All right, and before we click on that, I will just have to explain you few stuffs here. This Wireshark utility, right, it works based out of inverted TCP IP model, which is very similar to how an OSI model works within the computer networks. It's very simple to the OSI layer model. Okay, let me open up a browser and explain you the difference between what is an inverted TCP IP model as well as what is a OSI model. Okay, I'm just going to say TCP/IP model versus OSI model, and I will show you what's the difference between both. So guys, the TCP/IP model, right, it's very similar to what an OSI model looks like. For example, the network interface, right, there is no data link or physical in TCP/IP model, but both constitutes a network layer. All right, and then network layer on a TCP/IP model is called as internet layer, and the transport layer is as usual a transport layer, and there is no presentation or session layer. I mean, all the three layers, application, presentation, and session layer, constitutes an application layer. All right. So this is how a TCP/IP model works. However, why Wireshark works on an inverted basis is that I will show you that just now. All right. What I'm talking about when I say it's in Wireshark works on a inverted TCP/IP model. All right. So here you go, and I'm just going to start capturing packets in front of you, right, by clicking on start capturing packets or start capturing the traffic. Okay, now it has started capturing traffic, and I'm just going to quickly show you what all these sections or these uh, interface looks like, and I'm just going to name all the things here. Firstly guys, this section, right, this vertical section over here is called as timeline or packet list. All right, and this detail, right, this section over here, it's called as packet details pane. Okay, and this section, right, this overall section, it's called as raw packet or hex dump, this particular section. Okay, raw packet or hex dump section, or pane you can call it. So these are all the namings that you can learn from what I have said to you. Right, and let's quickly begin on the inspection part over here. Right, and let's do one thing here. Let me begin a ping request. Let me start capturing some ICMP request. I will say ping space 4 -4 space youtube.com and hit enter, and it will start capturing the ping request. It will start the trigger the ICMP requests, right? And I will just quickly go to the Wireshark section. Now as you can see here, you will be able to see all the ICMP requests continuously flowing. All right, you can see here, you can see the YouTube, right, this one 142.250.183.238, which is the ICMP request, the YouTube server you can call. You can see here it's the same IP address, destination IP address that we have started ping capture on. You can see here it's continuously flowing. All right, 142.250.183.238 over here. It's a ICMP request. Actually, we can quickly filter ICMP packets alone by just typing ICMP over here and hitting enter, and this will only show ICMP packets, guys. This is how you use the filter. All right, and you can see here, you can see that ICMP packet captures are displayed over here currently. Okay, and what I'm going to do is I'm quickly going to open up a browser for you, Firefox session, and quickly going to visit youtube.com. all right, so that's YouTube page opened for you. And now what I'm going to do is I'm going to quickly filter the traffic that's hitting the YouTube server by just typing TCP contains youtube.com, or you just YouTube, and hit and say enter to it, and you can clearly see the traffic or the packet being captured to the server between my source computer over here and destination address. Okay, it's coming up. Okay, basically, so you can see here, guys, I just typed TCP contains YouTube, and you can see here source, this is my computer's IP address where I'm running Wireshark capture, as well as this is the destination YouTube's IP address, right? You can see here it's the same IP address that's being used by YouTube. All right, I mean same it falls under the same subnet basically. Okay, and I will confirm my IP address just now in front of you, which is ifconfig. I'm just going to type, right, and you can see here my IP address is the source machine from where I am trying to hit the YouTube server, 192.168.0.7, which is the source IP address being displayed over here. So what I've done is I've just filtered the TCP communication. Okay, and you can see the protocol as well, which is the TLS version 1.3, which is the more latest TLS protocols that Microsoft has launched, and as well as TLS until TLS 1.2. It is going to be a vulnerable TLS protocol if you're still using the TLS version 1.2 protocols. Okay, and this is how you pull a TCP traffic, okay, that is containing youtube.com DNS address. All right, and when I spoke about the inverted TCP IP model, right, just give me one moment here. What I'm going to do is, let's say I'm going to filter for a traffic, just DNS traffic, and I'm going to hit enter, right, and otherwise let's say I'm just going to filter for HTTP traffic and say enter. All right, so this is the best example that I can show you and explain what is the inverted TCP IP model that I was talking about in the beginning stages of the video. So see, guys, when I say inverted, right, so when I said inverted TCP IP model, what I meant was, as per the general TCP IP model, application layer comes first. However, when it comes to Wireshark, application layer will fall in the last category. So basically it will be inverse of what is generally shown of what an TCP IP model is just now. Let me show you from a Wireshark point of view. So see here, these two layers, right, these two layers will form a network access layer. The first one, you can see here, this one, which is talking about some wire, right, it's a physical layer. Okay, physical network layer. And the second, Ethernet 2, which is the default gateway, which is my router. That also, these first two things constitutes a network access layer. And the second, internet protocol, right, this one, the third one forms the internet layer. Okay, where it says internet protocol version 4, which is the internet layer. And the third one, transmission control protocol, right, this one constitutes a transport layer. Okay, and the last one, HTTP, hypertext transfer protocol, this one, let me expand this for you, which has a browser session. Okay, basically this is your browser session, guys, which is the application layer. You can see here application. This is the application layer, which is the HTTP protocol, which stands out as the application layer. So this is how it works. The application layer comes in the last, wherein the network access layer comes in the beginning. These first two this first two sections over here. So that's what I actually meant. Wireshark works on inverted TCP or IP model. All right. So it is clear. I hope this is clear for you. Okay. By the explanation I have given it over here, the first two layers, the first two segments or the parts constitute a network access layer. The third one, right? Internet protocol version, which shows over here, is going to be your internet layer, and the third one, transmission control protocol part here, it's going to define the transport layer, and the last one, hypertext transfer protocol part over here, which is going to be your browser session or your application layer. Okay, I will just show this TCP/IP model in front of you for a better understanding. You can see here application host to host means the transport layer, which is marked in green color, and the internet layer, which is going to be your IPv4 thing, and network access, which comprises of data link and physical layer. All right. So this is how it works, guys. And furthermore, what I will show you is I will show some more filters for you to understand it better. Okay, let's say I want to capture a traffic pattern between a source and a destination machine alone. Okay, I just want to see packets being captured from a particular source to a particular destination address. How am I going to do that? So let's begin. What I'm going to do is, and before I jump into this, guys, if you want to learn more about the filters thing, just go ahead and click analyze and say display filters. It's going to give all the predefined filters that are available for you to learn. It's just like a manual you can make use of. Filter name will be shown and the filter expression is given over here on the right side. Okay, this is how you can learn all the basic filters that you want to learn and use in your daily activities. And however, I'm just going to show a sample filter again. I'm just going to put IP address is equal to. Okay, and what I'm going to do is I'm just going to give my machine this source IP address machine, that is my machine where I'm running Wireshark just now, and say and specify the IP address as this is the source IP address filter. IP address space is equal to space 192.168.0.7, which is now currently specified as the source over here. All right, and now what I'm going to do is I'm going to specify a destination address. All right, let me just quickly see what I can give as a destination address. Okay, let's take this YouTube's address as an example. What I'm going to do is I'm just going to right click on the YouTube's destination address and just right click on it and just say apply as a filter, and then what I'm going to select is and selected, the third option over here, and just say okay to it. But unfortunately I'm not seeing any packets that is traversing just now. So guys, I'm not seeing any DNS requests from my source machine to the YouTube server. So what I'm going to do now is I'm just going to switch another filter. What I'm going to do is I'm just going to pull ICMP requests from my source machine to my destination, that is my router, okay, or the default gateway. What I'm going to do for that is just say ip.source space is equal to I'm just going to specify my source IP, which is my machine. Just now let me, so I'm just going to say, guys, ip.src space is equal to and then space my source IP address. That should be an open close braces. Okay, and I'm just going to say hit enter. And what this does is it just gives all the packets that are being transferred between my computer and my default gateway, which is my router's IP address over here. Okay, now what I'm going to put another filter is that I'm going to just right click on my router's IP address, and after that I'm just going to say apply as filter, and I'm just going to say and selected. All right, and after that what I'm going to do is, you can see here, so guys, let's do that again. The previous filter that I applied only had the ICMP packets, that is from my source machine 107 to my router's IP address, that is 192.168.0.1, had only ICMP requests that are flowing just now by default. There was no TCP traffic or HTTP traffic, hence I could not filter just using I mean I could not filter with just one traffic flowing to just one particular protocol. Okay, so what I'm going to do is, I'm just going to redo a filter for you. What I'm going to do is, I'm just going to type IP. So I'm just going to paste a filter that I had already copied. Let me paste it in front of you. So what I've done is, I'm going to use my source machine. Okay, that is 192.168.0.107, and I will put and I have just taken this particular IP as the destination address. This is an IP address hosted by Google's public IP address. And what I have done is, I have just right clicked on that, and as usual I have selected apply as filter and just selected and selected, and it has auto populated me this filter. Let me show you this up again, what I have done exactly. I will remove this up here for you. I've just typed ip.source space is equal to my computer's source, my source computer's IP address. And after that, after which what I've done is, I've just right clicked on here and just said apply as filter, and then just said and selected. That has automatically given me this filter. And as you can see here, the traffic has TCP protocols traffic capture, the packets flowing via TCP protocol, as well as I have the traffic capture, that is the packet capture happening via TLS version 1.3 protocol. So if I let's say if I want to just filter the packets that are flowing via TLS 1.3 protocol, along with excluding the traffic flowing via TCP protocol, how am I going to do that? I'm just going to hit a space and then just add an and then I'm just going to say TCP here, and I'm just going to hit enter for you. And as you can see guys, this filters the traffic captured via TLS version 1.3 protocol alone. It has excluded the TLS version 1.3 protocol. Okay, sorry guys, it was my fault. I had typed TCP. I have just added TLS over here, replace TCP with TLS, and that allows me to just view the traffic that is flowing via TLS version 1.3 1.3 protocol. And the TCP traffic is now hidden because I've excluded TCP protocol from my viewing, and it's just TLS version 3 protocol visible in front of you now. All right, as you can see, there is no TCP traffic or TCP packet that's being captured over here, just TLS version 1.3 protocol traffic that we have filtered upon. What we have done, we have added the source machine's IP address, and we've given the Google's public IP address over here as destination, and then we have put up a filter adding and then saying we just want TLS traffic as visible, right? And that allows us to just view our traffic that is getting that's being flown via TLS 1.3 version protocol. Okay, so that's how you do it guys. And then I'm just going to quickly show you one more thing here. Okay, often you might have learned that the HTTP websites, right, mostly they are nefarious websites. meaning all the information that gets flown via the HTTP website is in a readable format. You can easily sniff in the information that is being flown via an HTTP site. Okay, I can give you an example and a demo. Like for example, let's say I'm opening up my Mozilla Firefox browser, right? Just going to open. I'm just going to open a test website for you, which is by default an HTTP site, and it's intentionally vulnerable site. This is the one which I'm talking about, right? And I'm just going to quickly log in. I'm just going to put login.php, and here you go. So what I'm going to do is I'm just going to put the username, which is test, and as well as username is password, and I'm just going to log in to this nefarious site over here. Okay, this is going to say don't save, and as you can see here, I have successfully logged in. Okay, this is open source website that is used for website security penetration testing purposes. If you are new to let's say if you're new to penetration testing, you can use this website to learn more about website penetration, website security testing. Okay, this is a mock website. This is intentionally vulnerable website. So as you can see here, it is a HTTP site. You can see there is no certificate to protect this website, and the connection to this website is not secure, insecure. So this one is a test nefarious website, I would call. And what I'm going to do is I can actually quickly sniff in to read the username and password. Okay, so that's the reason always your elders say do not visit HTTP based websites, because they are generally nefarious. So attackers can easily sniff into your username and password if you are trying to access or access a nefarious website containing HTTP protocol, and you're putting in your username and password there. Now I can just put a filter here. I will say TCP contains uname as in username. All right, you can see guys, it's automatically, it has pulled the traffic. Okay, and this is the destination's address, as in the IP address to which that nefarious address resolves to. You can see here the HTTP protocol which I was talking about. It's not a secure protocol. And I will just move into the last bit where I can actually read that information. So I just scroll this bar over here guys to the utmost end of the page. Okay, where I said hex dump, right? All these are packets guys, small packets, okay, that constitutes the actual message. Like if you had watched my previous video on what a packet is and how it works, you could have gotten an understanding that everything on internet happens as a series of packets, and all those series of packets are assembled to form or constitute an actual message. So you can see here a lot of packets are constituting to this actual web page login. Okay, and at the end you can see here all these small packets constituted the username, which is equal to test, and password, which is equal to test. Okay, you can easily sniff in this information if the website is a unprotected website, which is unencrypted website. This can happen only if the website is a unencrypted website that does not have a SSL certificate to protect it. Okay, and you can see here clearly username is visible and also the password is visible. All right, so this is how you do it guys. This is how Wireshark works to the best of its potential. Okay, and henceforth that is why we always advise to not visit nefarious websites. All right, and that's all guys. I think almost it's 25 minutes to this video, and if you like this video, please hit the upvote button and also share this video. We will meet up in the next video with more useful content like this, and until then, eat healthy, stay safe, cheers, tata, bye bye, thank you.